unfortunately, yesterday we were the lights, the network went off here, so we couldn't finish what we were doing, and so we just have to. So this is the result. This is not. It doesn't take. It just it takes long to run, but the procedure is simple. The procedure is simple. And if you remember, I said that this type of estimate, or let's say interpolation, is used to subdomain. If you have veins like this, like these ones, you can use it to subdomain any of the domains. If you don't have them, yes, you can still use these ones to estimate. Just that is the control is very minimal. It's more of parametric than human control. So you estimate. So these are your grade beans or your cutoffs, 0 to 0.5, which is the width here, and 0.5 to 8 here, and then above 8, which is the MF. So it's the matter of knowing the procedure. I think, yeah, so this one is the domain, the main domain that we subdomain. So inside the main domain, you have all these there. So what you do is you estimate the 0 to 0.5, different estimates, the MO different, and then the MF different. Then after that, you add more them together. That is the essence of this. Today, if you were not here, the current video, which is part 7, is in the server, so you can access it and then watch. Please just put the videos inside your phones. Then you listen to them like you listen to music. Time comes when you just get the software. It will be very easy to manipulate your way through. So that is the trick. Just put them inside your phone and then be watching, be listening. Even if you listen, you put the phone in your pocket, you listen. You don't see it. When you get a chance to sit down and then you see it, it will be very easier. If you don't listen it often and often, you think it's difficult. It's not difficult. So the new RBF interpolant was that. This one, new multi-domain RBF interpolant, is just the same. It's just that this new multi-domain interpolant, that one, it will give you domains inside the domain you are subdomaining, and as well as what is outside your subdomaining. Yes, that is what it will do. So for instance, the domain, I can pick Parite, whichever I want to. I can pick the share, whichever I want to. And I can pick the domains, any of them I want to. So the numeric value, which is the RC, that is what I told you. The numeric ones, you don't need any merge table. You just use the RC straight. Don't need any lithology or whatever. Let's use the assay straight. So you can pick any of them, which one you want to subdomains inside. Any of them, let's pick them. So I'll leave it the share to be attached to the AU, and that indicates that I'm domaining the share. So I just click OK. Yesterday I spoke about the compositing, and I told you I've spoken about the query. If you have lots of maybe Cat2, Cat3, you want to model only Cat2, you just have to know that the difference, whatever attribute in the data that differentiates Cat2 from Cat3, you just have to have that. So if you have whatever differentiates, the attribute that differentiates Cat2 data from Cat3, maybe you have introduced a column called PIT, and then all Cat2 data, you've put there Cat2, Cat2, Cat2. So you just go and query it. Leave, I showed you this some time ago. Just query it. You just build it, and then you will see if you have that, or this data set. If you have, you just see color data set is, if you have the data set name, just put it in and apply. So all these things will come, and then you save the query. So we have Asanko, Obotan, Obotan GC, and we have PMI. So whichever you want. So when you apply, this is the Obotan GC data, where you just save the query. Obotan GC. So that is the query. It should be safe. To be safe here. Sorry. So it will be safe here. It will be safe under the color. And that is what you use if you come to the query. So come to the query. So here you can select this, and you are dealing with only Obotan GC data. So if you have the PIT name to, you just query the PIT name where you want to work on, and you set the query, and that is where you are going to. But in this case, we don't have anything like that, so it's none. The compositing, I told you that if you have composited the data, then you don't have to select anything. It's already composited. But if you haven't composited the data, you either composite the entire drill holes or you composite within the boundary. It's good to select composite within the boundary because I told you that compositing, one of the disadvantages is that it can introduce some waste into your prior to estimation. And the importance of the compositing is just actually to make a better prediction of the mean, the average grade that we want to. And so it is important to composite, and the compositing also reduces computer runtime. So you can composite over bench. It's downhole. So you are composite every 1.5. You just divided the drill holes into equal spacing. So because you have samples, maybe your maximum sample length or your dominant sample length is 1.5, you could have 0.2, 0.3. When you are logging and you get to a particular lithology, maybe you have 0.5 granite. You don't want to lump it with meta sediment, so you want to sample that alone. Or you have 0.5, you have a visible gold. You don't want to smear the gold throughout maybe 1 meter. And so what you need to do is you sample where you have the visible, so that it wouldn't get a chance to smear throughout the 1 meter interval. Or maybe change in lithology you want to. And so you have small samples in there. The residual 0.25, that is the minimum. If you are compositing down the hole, and maybe you have 1 meter, the last smaller sample, if it is less than this, what should the software do? Should it discard it? So usually it's good to distribute it equally. So it means that it will be added to the preceding length, and then add it, and then give you the required sample length. That is the 1.5 as it goes down the hole. The minimum coverage is the minimum percentage of samples to be included in your compositing. And so 50% is good, either 50 or 75% is good. So that is that. So the domain is already the share, the value transform. I want to explain this extensively when I get to statistics, geostatistics proper. But this one is just giving you the maximum sample length. So the trend, we have that is the ellipsoid radius. And when you model, because they are actual shells, just some little wireframes around the grace. And so when you are done, you see some to look like balls, round like circles. And we are saying that in real situation, earth material is not, cyclic, or it's not circle. And so it's either ellipsoid. Some software will say ellipsoid, some will say ellipsoidal, some will say spheroidal. They are the same. So it has radius or distance. And you know our all body strike is northeast, southwest. So along the x-axis, which is the strike, is always giving the maximum ellipsoid ratio, and that is why we give that one 3. Other softwares is 3, 1, 3. When you are doing the estimation, and you get to when you are doing variography, you are using supervisor. Determine format is 3, 1, 3. That is ZXZ. But this one is using maximum, intermediate, and then minimum. So that is that. You can use this one as a global trend. But in our case, that is the global trend is used when you don't have a structural trend. But we created a structural trend, and we use it for the first one. So we can use the structural trend, or we use the global trend, whichever we want to. But we created a structural trend, and that is this. And I think the part 2 or 3 of the videos that we created a structural trend, if you have missed that, I think it's good to have a look at it in one of them. The interpolant. Interpolation. I know in English you know the interpolation already. This is where I said it's parametric. So this one has parameters. These are also parameters we are putting in. So by default, it is linear, and we are saying that earth materials are not linear. They are not circles. The earth is not a circle. In other words, the earth is not a circle. It's ellipsoidal or spheroidal. And so we select that the spheroidal. And I think I explained these ones yesterday. And I want to the sill and then the range, the base range. We'll explain it into details when we get to varography. But what if you haven't seen varography before? What you are seeing here is an example of a varogram, a semi-varogram. And we will say that where the varogram plateaus or levels off, the value of the semi-varogram corresponding to the y-axis. So you see that it will start from the origin up to a point, then it flattens like that. We say plateau or flattens or level off. So here is what we, so when you look at from here going this way, it levels. So that's what we call the autocorrelation. So the value here increases. At a point, it remains the same, flat throughout. So at the point that it begins to flatten, and that value corresponding to the y-axis, the interpolant here, that is what we call the sill. So that's what we call the sill. And that on that point going down is called the range. So I just giving you some small overview. When we get to varography, you will understand it better, because this is just an interpolation, wireframe. And I explained that in a real situation, nugget cannot be 0, 0. The nugget simply is the value of the semi-varogram from the origin. The value of the semi-varogram from the origin, that's the nugget. And in real sense, as a Jew, when you take a sample from one point and then you duplicate the sample and then you analyze in the laboratory, what it is telling you is that the differences between the duplicates is 0, 0, and it can never be like that in the gold mine. You can never get it 0, 0. You subtract the duplicates and you get 0, 0. It can never happen in the gold mine. And so that is false here in terms of geostars. So, but because this one is interpolation, we leave it like that. So that's the interpolant. So when you come to the output, you have the minimum grade and the maximum grades here. You have the surface resolution, and I've explained the surface resolution. So I told you that is the triangles, the wireframe. You know, the triangles forms the wireframe. Individual triangles forms the wireframe. So it's the length and breadth measurements of the triangles. So that is the surface resolution. The smaller the surface resolution, the finer or smoother your wireframe. But it depends on the wireframe that you are creating. If you are taking something like the whole Esansi topo, or okay, that one is just a topo. So let's not say, just take a whole, let's take the sulfide boundary. That one is bigger. And so because that one is bigger, if you are, because the sulfide boundary is bigger, if you are going to put a surface resolution of 5, it's going to take a very long time to run and give you an output. And so even though it will be fine, but it will take very long time to run unless you have a very good computer. Yes. So, and I explained that the graph, if you take graphite, for instance, graphites are usually very, very small, tiny veins. And so if you model graphite, you need to give it a surface resolution of maybe 5, yes, 5 or 6 or 7. That will do. But normal domains, I think 8 to 10, that will be fine. 30 will be too much. It won't give you a realistic wireframe. So by default, it will give you the bins. The bins will be provided by default. So these are the default bins. So you now have to change them to suit what you want. And so you use the plus to add, use the minus to remove it. So you highlight and remove, highlight and click to remove it. So I want to edit this one. So I'll give it 0.5, 0.8. So 0 to 0.5, 0.5 to 0.8, then greater than 8. So that is that. So you okay it. I'm clearing this one and allowing this to run. If you have any question, please let me know. If you have any question, you can let me know. This software things. It's about determination. You determine to know it. And once you are able to know one software, it will help you to know another software, because the softwares, they are basically the same, just that their approaches are a little different. Yeah, their approaches are a little different. And I don't think, I'm yet to know a mining company in Ghana that still uses SEPAC or wireframe, SEPAC or data mine to create their wireframes. I'm yet to know. Like, most of them have migrated to implicit, and that is why data mine is now coming up to be able to, compute, because I'm sure they are getting there, but not up to, not flexible like Leapfrog. The implicit modeling is there, but it's not flexible like Leapfrog. I'm sure until they separate the implicit modeling aspect and then make it proper, it's not easy. So even though there's no, license, but you need to watch the videos. You need to watch the videos and let it be in your mind. And anytime you get the opportunity to grab the lines, then practice it. And it is when you just look at it today and put it down, no softwares, a computer in general, you don't practice, you forget that one day. So once in a while, you have to just make sure you go through. Okay. Are there some of you who have used supervisor before?
Right?
Yes.
Yeah, from the sunset, none of the team.
Come again.
Yeah, you asked a question whether anyone has been exposed to supervisor.
Yeah, I was asking whether are there some of you who have used supervisor before?
From a certain mode, no, please.
There's one thing about this. It takes a long time to run. So if you don't have, what I want to say is just you go and read about varograms, so that when we start with that, you will understand better. You know what? That's all about the multiple domain interplant. So once it is going to take long to run, the next step is just to drag it and drop it in the screen and explain why. Explain certain things there. So for the sake of time, I suggest that we just kill this new indicator RBF interplant, and then possibly another time we have a look at the two output. What do you think?
Please, could you come again? You were breaking.
What I'm saying is, it takes a long time to run. So for the sake of time, I suggest we just do the new indicator RBF interplant, so that the next meeting we can just pull them to the graphics and explain. What do you think?
Okay, that'll be fine.
Because we'll be sitting and waiting for it to finish running, and it's about 55%.
Yeah.
Okay, so the last one I want us to look at is the new indicator RBF interplant. This one is the same as the concept, the same as the intrusive one we did. It's just that this one doesn't need any merge table. It's also done within a boundary, or is done when you want to subdomain. So note the difference. So now, when you right click new indicator RBF interplant, you select your assay. Then you see cutoff. When you hear cutoff, indicator or threshold, cutoff, threshold, they are the same. Indicator, or you say, when they say what indicators do you use, they are just threshold, they are the same. They just geostatistical terms. So greater than or equal to 1, that is the cutoff by default. So we have to also determine what cutoff we want to use. So I can say that you see the filtering has come here again. If you want to filter any of your interest to model, you do that. You apply the filter. The enclosed objects, I have explained that. So I'll pick the share extend. Compositing. If you have composited the drill hole data before using, that is it. If you haven't composited, just pick some. Because we haven't composited the drill hole before using it, it's giving us one missing numeric data. It means that it doesn't have compositing field in the data. But we just have to give it. Simple elements. So surface resolution. The ISO value, it gives you the increment. So 0.5. So once you've given it 0.2, the increment, you can leave it like that. That is the increment. You can leave it like that. You can change it if you want. So It's up to okay. So this one will be created inside and outside. You have to activate it with the let me apply the tuple. The tuple will come and take, when the tuple is activated, it will take all this away. So what you are seeing is where the axes are. Can you mute your ends? Okay, so that is it about implicit modeling, the vein, and then the numeric approach. So we have done the vein and we have done the train numeric approach. That's all about the numeric approach. And so what is left is just to drag them into the scene for you to have a look. So if you want to go somewhere, we can close, and the next time we meet, and we just have to drag them. I'll have to polish. I have to make sure that I trim all the veins so that we will use them to run we export them. Click, right click, then we export. So we export them, then use them for our estimation in DataMine. But we first of all have to run statistics using the supervisor. We will domain the sample, the drill holes samples in Datamine, and do cell width or cell WF in Datamine, export them into supervisor, run our classical statistics and do statistics there. Then do our cappings and go back to Datamine and run the estimate. So please, you need to be serious. And yeah, so Datamine, if you have excuse for leapfrog, Datamine you don't have excuse. So after I have run, I would want you people to go and try your hands on. Just to get a basic understanding of the approach. But it's not the basic, it's the advanced actually. What I'm going to show you is the advanced way of running it in Datamine. So I can, when I finish the wireframes, I can export the wireframe and put it in a server for everyone to pick it and then run it on his or her computer. So we call it a day. Any question or suggestion or whatever you want to say?
So, Clet.
Yes.
Yeah, I wanted to find out. So, after our GC drilling is done, and the GC model is supposed to be done, will you be going through all this before you end up with the model?
Okay, so the early stage, when exploration drilling is done, and you get the data, what happens is, it is that data you use to go through all this process. And when you go through all this process and you get your parameters right, then you now feed them into the script. And that is where we now have section by section running the GC model on section by section. So we're using those parameters, the resource model parameters, to run our grid control model. But intermittently, there could be some changes. For example, the density that you sample, maybe once in a while we have to look at the density because the density is a factor of the tons. So we need to update the density. Maybe once in a while we look at our capping, and then if we need to revise or review it, we can do so. But most of the parameters are from the resource model that are inside the GC. So the GC model, you don't go through all this procedure. You just have to use the whole parameter that is in the script to run the GC model. Just a small portion where you are mining. That's it.
Okay, thank you very much.
Clet.
Yeah.
Clet.
Yes.
So if I get your explanation, that means all that we went through is to create something like a base model. Is that it?
You're creating the resource model. That is what they have done. That is what you go through to create the resource model. And that is what the planners use to do their planning. so that when we now run the GC model, then we do some comparisons with the resource model to see whether the resource was overestimated, because the resource model do not have enough data, but the GC model has. So the danger is if you don't have enough data in the resource model, and you have a high grade, maybe you are getting one drill hole passing through a certain section of the wireframe, it is going to smear two out at a certain distance. So it gives you very high grade of that portion. And maybe the high grade is pinching out, the ore is pinching out, but just that the ore has, I mean, it happens to pass through that it has, I mean, the corn, the area to be like a very high grade, meanwhile it's not. But the GC will come to validate that, because that one we usually have enough data.
Oh, okay, thank you.
Welcome.
Let's.
Yeah.
Yeah. So I wanted to find out, assuming exploration is done, and they have their listing, their assets available, all the results available. Is it exploration who is supposed to go through these procedures to get the resource and later hand it over to you? Not currently, you are with mining, or you have to take the data and start from the basics to mining. That's what I want to know.
Okay, so my former company, that is what we used to do. Once you get the exploration has done their drilling, has finished their drilling, you just have to extract the data from the database and run through all this just run from the scratch to your handover node. The models that we run comes with handover nodes. Yes, and this is what the
wrong pack.
yes, yesterday we didn't get a car. There was no car to go.
Did you do it today?
The guy is gone. So if you know Eric Chen, the former VP, Vice President Mineral Resource.
Yeah.
Remember him?
Yes, please.
Yeah. So he used to do the resource model.
Okay.
He used to do the resource model. So the exploration people, maybe they just want to. I don't know who does resource model, but mostly is Richard who does that.
Okay.
But now we're trying to, this new manager that has come, we are trying to work hand in hand to do it together, so that it wouldn't be only he is doing it.
Okay.
If there are no more questions, then call it a day.
Thank you very much.
Most welcome.